Start with a and b relatively prime, and insert c1, c2 through cn in between them in continual proportion. So we have a to c1 to c2 and so forth to cn to b. We'll show that we can insert n numbers between 1 and a, or b, just as we did for a and b. First, we use the ratio of our given continued proportion to make the continued proportion e to f in least numbers proportional to that ratio. Then, construct from e to f a continued proportion of the same length as the given ratio. The continued proportion will be e to the n minus 1 times f, to e to the n minus 2 times f squared, and so forth to f to the n. A and b are relatively prime, so our given continued proportion is in least numbers. E to f is in least numbers, so e and f are relatively prime, so e to the n and f to the n are relatively prime. So our continued proportion is in the least numbers as well. This means our two continued proportions are equal, so that e to the n is equal to a and f to the n is equal to b. We can therefore make the continued proportions e to the n to e to the n minus 1, and so forth to e to 1, which is a to e to the n minus 1, and so forth to e to 1, and f to the n minus 1, and so forth to f to 1, which is b to f to n minus 1, and so forth to f to 1. So, we've done what we've set out to do.